Так, привіт всім. Вітаємо всіх на цьогорічному святкуванні 4-ліття ROS-Ukraine. Як ми вже склалася, така зовсім невеличка традиція з святкування 3-ліття. В нас було 3 роки, 3 доповідача. Зараз в нас традиція продовжується в тому відношенні, що в нас 4 роки, але 3 доповідачі лишаються. Ось і 3 дні підряд з цікавими доповідями. Сьогоднішній день так само досить, і сьогоднішня доповідь від Ільї доволі цікава тим, що, як я вже говорив перед початком, буквально пару хвилин ми з Ілією говорили, про те, що на Марсі здійснив перший політ дрон виробництва НАСА, і як я слухав в «Голосі Америки», якраз українець скажімо, був залучений до розробки цього дрона. От і сьогодні Ілля буде розказувати про розробку саме дронів. Він працює в компанії BladeInsight. Ось компанія займається досить цікавим бізнесом. Вони досліджують, а перевіряють стан гвинтів вітроелектрогенераторів. Ось це дуже цікава задача. І, в принципі, пригадую, попереднього року в нас виступав якраз доповідач Євген Засоба, і він якраз розказував, у нього одна із тез була, де ці роботи, про які всі говорять, які практичні задачі ці роботи вирішують. І оце дуже приємно, що Ілля сьогодні буде представляти нам свою роботу, яка фактично несе прикладний характер. Тобто це роботи, які приносять користь суспільству вже, тобто не завтра, не післязавтра, а вони вже приносять користь суспільству, ну і відповідно заробляють гроші тим, хто їх створює. Так що пишіть, значить, організаційніше питання. Наш спонсор, компанія SoftServe, який велике окреме дякую за організацію цієї прекрасної події, ось вже другий рік поспіль, буде роздавати подарунки. Значить, подарунок – це буде цікава книжка, в якій буде згадано, перший раз було згадано слово, що один з перших разів було згадано слово «робот», книжка Карла Чапика. Ось, і відповідно Ілля визначить переможця на основі найкращого питання. Тобто питання ми задаємо в чаті, в кінці я їх або організатори їх озвучать, і Ілля вибере, яке питання було найкращим, і цій людині, як говориться, відійде приз. Ось. І ми будемо розігрувати призи всі 3 дні, так що залишайтеся з нами всі 3 дні. Добренько. Передаю слово Іллі. Ілля, the stage is yours.
Спасибо. Добрый вечер. Я не знаю, все ли уведомлены, что презентация будет на английском. Так как я всю свою карьеру проработал на английском, мне намного проще говорить, или намного сложнее было бы сделать презентацию не на английском. Поэтому одну секунду. Видно экран?
Так, бачу.
Okay, so let's start. And our presentation today is focused on best practices for reliable robotic software, continuous integration, and delivery. And I hope that I will be able to share all this baggage of experience that I got throughout those 8 years that I've been working in the field, and I can share it with you. I might not have a lot of presentation experience, so in case I might be a bit nervous, but I have a lot of things that I would like to share, so I hope that it will be something interesting for you. Let's start with my background. So I started my studying in Kiev Polytechnical University. Then I did my master's degree in Warsaw as well, Polytechnical University, and there I got involved for the first time with the drones. There was like a student team there where I programmed mostly on the low-level microcontrollers and the sensors for some competitions that we eventually went to. Then I've been working in Denmark for 1 year in Copenhagen, in a company that calls Danish Aviation Systems, working on very different types of drones. And after a while, I moved into Portugal, where with 2 other guys, I joined the company at the very early stage. So it was like half-a-year-old company. I was the 3rd employee. And from then on, we grew to a company that's right now called BladeInsight. We changed our brand last year. And at this point, we are 20 people. So from 3, we grew to 20. Here's just some projects that I've been involved with. And then I will speak a bit more about what is our company focused on right now and what we are doing. So here you can see some examples of the project that I've been working in Denmark. This is the drone we did for the military that was supposed to find radioactive materials in some fields, so just with some simple sensors, and we're supposed to send the GPS coordinates to the ground control station. Some drones that are focused on taking photos of the crops and investigate how they are evolving or how they are growing. Some drones for the firefighters with the cameras, with the how's they called, clear cameras, the sorry, I forgot the name of those cameras, but they can see in non-visible spectrum with basically determine where's the heat coming from. And those images here show the early stage of our development in Portugal on our company. As Andriy already said, we are working on inspecting wind turbines blades with using drones. But what's differentiates us from other competitors is the way we're doing this. So instead of manually piloting the drone, we have a software that is running real time on the drone that is able to autonomously inspect those turbines. So as you can see, this is like very early stage of development here, where we tried to lock the blade, or whatever is there signifies the blade. This is a bit later stages of development. Please remember this photo because I'm going to speak about it later on. And this is our first client in Brazil. It happened 3 or 4 years ago already, where we were delivering the product. And these are, I think, 2 years ago, some beautiful place. And just speaking a bit more about what is our company doing and focusing on our product, just for you to have a better understanding on the complexity of the robotic solution that we are delivering. So basically what our company produces is not the drone itself, but the payload. So it's one thing that is attached here to the drone, and it can support different type of the drones. So we can be drone agnostic or autopilot agnostic. As long as we have the API or SDK to control the drone, we can put our payload to any drone and just tell it where to go. And this payload has a set of onboard sensors such as LiDAR, cameras, several cameras that once get used for navigation or for collecting the data. And in real time, it is able to recognize what is the tower, what is the blade, and without any input from the pilots, being able to survey the blade from all 4 sides, taking images with the specific overlap that is specified, and basically do everything automatically and repeatedly, independently from the shape or the model of the turbine, because those shapes can be very different. And that's what is also important for our presentation in the future to keep in mind. Now, about the content of today's presentation and what I'm going to speak about. The way I see CI process, or continuous integration process, and I'm not sure if everybody is aware what is the terms means, but the way I see it is like having one very attentive to detail person in your company who is constantly verifying what is your team doing and checking if everything is working after whatever change has been done to your product. Except that you don't want to have that person, but you want to have this process completely automated and have a computer to do this job. In some cases, it's completely feasible not to have this continuous integration process or not to have those tests in place. For example, in universities, when they just need to write a paper and prove that something can work in the lab, or when you are in the early stage of the product, when you just need to build a proof of concept for some specific algorithms. But the more complexity of your project and the product grows, the more it is required to have some automatic tests to be in place. And in some cases, it's completely impossible to have a product on the market without having those extensive tests within your company and having those processes. For example, such as an autonomous driving cars. Even though I'm not involved and I haven't been working in this area, but I'm sure that they have a huge department of the company that's purely focused only on automatic tests, and every time that there is an update in the firmware to make sure that the program works and it reacts to the environment in exactly the same way as it is expected. Before we will get into continuous integration and delivery process and talking about specific parts of it, I would like to discuss, following that analogy that I did with the person, I would like to discuss what kind of tools and processes we as people have in order to verify our work, and what kind of things we would do in order to verify that whatever changes we did are correct and the product is still working as expected. And I thought for a while what to start with. And as for every person that starts in our company, they are starting from the documentation and onboarding process. It is very important that within your company, any person that joins understands how your system works as a whole. And the first place where any new person that comes in should land, or normally lands, is the onboarding page. It is very important that this page is as much updated and organized as possible. It's a first place where this new hire or developer introduced to your culture and the quality of work that your company delivers. So that's why you want to set a high pace for the developer, and you want to show them that you're working in the serious company that develops world-class products. Within normally this onboarding process, make sure that this person knows all the tools and the workflows that is happening in your company and that it's clear. Make sure that your product high-level architecture is understandable. For example, if you're hiring a robotic developer to your company, he should not only understand how different programs within your robot work together, but how does this product brings value to your company as a whole. Because it might be possible that without having this high-level understanding, your developer will be developing something that is not actually on the roadmap, or that doesn't have high priority, or doesn't go within the goal of your company. And if documentation is outdated for some reason, your onboarding page encourage your new hire to contribute, and it will give him confidence in the company and that his opinion is valued. High-level documentation. Your developers should understand well your system. They should know really well how the architecture works and how the different parts and different nodes of your program connect to each other. And I will show you some example afterwards. Another part that I forgot to mention, I put some icons like this. For me, not to forget, it's some situation that I had in my career previously that I learned the hard way, some mistakes, and I would like to share it with you. And every time that you will see this icon during the presentation, I will mention something about some things that I was doing in the wrong way, and then I changed my mindset afterwards. So, coming back, easy to use platform for high-level documentation. There are many platforms such as Confluence, GitHub, Nutlino, or whatever, but normally for any developers, it's a pain in the ass to do this documentation. Everybody wants to have fun, everybody wants to deliver something that works and brings value, or that's something that you can show to your manager, but nobody is inclined to document those things. So make sure that this process as convenient and is easy for the developers as possible, so that everybody within the team stays on the same page. Make sure that you also have glossary for any product that you are developing. One situation that I had in the past, maybe 2 years ago, I had a developer that has been working probably for 2 weeks on one specific problem. And just because we had miscommunication on what does the waypoint means, and normally when you're trying to solve a complex problem within some product, you will start to develop a lot of abstract terms such as waypoints, I don't know, or what you would call the planning path, or any other abstract things that would specify either algorithm or a process within your product. So that person has been working for probably 2 weeks on a problem, assuming that, he was solving a problem, and we, even though we talked about the same thing and we called this waypoint exactly one thing, we were thinking about completely different things. And by the end of those 2 weeks, when it was time for him to show the progress on that specific problem, I understood that he was working on completely different thing. And the main problem there was miscommunication on those abstract terms. So make sure every time that you create a new product or a new program within your company, that you create a glossary page where all those abstract terms are really well described. Another thing about documentation, don't forget to write down all the third-party software, like open source libraries that you are using, and somewhere, and don't forget to document it. Every time that you will have a due diligence process during the investment, so that's I'm not sure if people are aware, but every time that investment comes to a company and your investors verifies that everything that you put on your term sheet or that you put on your business plan is true, every time they're asking for the list of third-party software, just to verify that you're not using some products that you're not supposed to without paying for the license. Now, next slides. Architecture and data flow. Make sure that you have somewhere a diagram of different nodes within your program connected to each other. For example, this is a diagram of the planning nodes that we have within our company, and it's been constantly updated and monitored across probably 3 or 4 developers. So when your program grows in complexity, make sure that you have a high-level vision on that program where you don't go too much into details, but just giving an overview on the data flow and the processes that are happening within this program. You can also specify on top of this layer some, for example, you can specify with different colors different threads that are running within your program. For example, in this one, there are 5 different threads that are running, and you can put a lot of extra information on top. Next, low-level documentation. Also, don't forget about putting comments in the code, documenting the algorithms, low-level algorithms. Make sure you use some tools similar to Doxygen or any other that would help you with this process. In our company, we also include into the pull request review process a check for whether the developer adds the updates the documentation within the code. And also make sure that you follow your glossary documented on the high level within the code as well, so it's much easier to find and to connect things within between different places. Now, from documentation, let's move into actual toolbox that you would have in order to verify if the changes that you are doing are still go within the scope of your project. One of the things that I also spent some time recently and some mistakes that we did in the past is we were constantly changing our style guides, deciding on which style guide we want to follow for different languages. And eventually when we, apart from that, apart from the style guide and formatting, we have included on the late stage of development static code analysis. So it's basically some checks that programs similar to Clang and C++ or any other programs for other languages that they do just by analyzing the code that you have. Try to include those checks as early as possible within your development cycle. One mistake that we did, we included them quite on the late stage, and we already had a lot of warnings or errors popping up, which it was really hard to change at such a late development stage. So we will have to create some white and black list for some specific warnings and others to prioritize them and basically spend a lot of time, development time, just on wasting, just for implementing those errors. There are some template projects, and I put some links here for C++ or Python that would already give for you a lot of best practices that you should follow when developing in one language or another that can save you a lot of time in the future and enforce on your developers following best practices or not to commit some well-known errors. Some other tools. Just this way. It is important when you're executing your program to keep a really close look on the usage of your resources, such as CPU, GPU, memory, or any others. You need to be able to reply to question whether my mission that I'm planning to execute, in our case, for example, survey Blade within 10 minutes, is it still possible given the hardware that you have? It is often, your robots are often limited to a specific computer or much lower CPU, so having such tools like this one on this image would help you a lot in order to debug your program and understand whether there are any issues with executing different threads, whether you are able to execute your programs in real time or not. Then profiling tools. As I said already, there are tools that would enable you to analyze your program in a way like it is shown here, where you can see on the separate lines here when every thread is executed. It is also often used in the game development, just making sure that you have a correct frame per second rate. And this tool helped us many times to find out some hidden bugs that are normally not seen just because you're not able to perceive information, I know, more than one event per half of a second. Simulation. And this one is the holy grail of the development tools. There are many platforms that you could use in order to perform the simulation, and it allows you to iterate much quicker on any development that you would do. 90% from my experience of your algorithms can be verified there. Another good point that you could break things there and nothing will happen. Your 20,000 drones will not hit the turbine, or even if they hit, nothing wrong will happen with that. Some experience that I would like to share with you on some things that we did pretty bad in the past is that we didn't invest enough time from the very beginning into the simulation. For example, if you remember in the beginning, I showed you an image of the like a metal construction on which you put sails around. So it's a boat sails in order to simulate the blade and the tower. So at that point, we spent probably not 1 month or 2 just welding this structure, putting it together, buying these sails and wrapping it around in order eventually to use it maybe 3 or 4 times. Because in parallel, we were developing the simulation environment, or we were integrating our drone sensors into the simulation environment. We use Gazebo. And as soon as we built that structure, the simulation was also done, and we ended up not using this outer structure almost at all. And all our development shifted into simulation. So you can save a lot of time, or make sure you prioritize your simulation environment, especially for a complex project, as early as possible, so that you don't repeat our mistakes. But what's the problem of the simulation is that it is hard to get the right error model, whether it's the model of your sensors or actuators, or the interaction between your vehicles within the simulation and the environment itself. For example, I cannot get the real model of the LiDAR. It's really hard to simulate it within the simulation, right? If it's a wheeled robot, the common problem there is that your wheel sometimes slips depending on the surface, whether you're on the ground or you're indoor, and it's also really hard to create all this complexity within the simulation. But it's enough for, as I said, to verify 90% of other algorithms. And one of the solutions in order to mitigate this problem is to use ROS-based. Since this event is about ROS, and I believe that many people are aware about what ROS-based means, but if you use any other robotics frameworks, it's basically a way for you to record all the data during execution of your program, and then being able to play or to reproduce this data in the same speed as it was recorded. When you're reproducing this pre-recorded data, or you play your ROS back, you would be able to mitigate those errors that I mentioned from the simulation. So basically, within the ROS back, you can go into the real world. You can fly next to the turbine and record the ROS back where you will have the real model of the errors that your drone has. You will have the real data from the LiDAR or from any other sensors that are located on your drone, such as GPS or anything else. And in this case, after you record those ROS back, and you don't even need to, at that moment when you record them, to run your algorithms on top, or you can do that. You can choose some specific data from those ROS backs that you can run your algorithms on top. In this way, you will have the real model of the error. but there is a drawback that you cannot actively change your environment. So basically, you will not be able to tell to the drone to fly to some specific location because the path is already predetermined. So this way of testing your algorithms or developing your algorithms is more suitable for perception algorithms or for object recognition algorithms, where you don't need to actively move your drone or your robot. Next one. And now let's switch to actual continuous integration pipeline and how all these tools and things that I mentioned before connects together. I remember our first introduction call with Andriy when after me telling him what is our company doing, that's what exactly is our product, he then asked me, so you probably also have in some integration, continuous integration processes. And at the time, it was, if you translate it from introduction language to the actual one, he was asking, so which league actually you guys play? So you're telling me that you have a complex product, but if you don't have any continuous integration in place, that means that most probably you have many issues with the development. Every time you do the release, something is failing, and for sure you have many issues with delivering reliability on the software side. So as I said before, any complex product, robotics product, requires, especially the ones that operates in real world on outdoor, requires CI processes to be in place, especially the product that requires scalability. So if from one day you want to, from 10 robots to move to 100 on 200 robots, you need to have those processes in place. And what are the tools for that? I show you here a more high-level diagram on how in our company it looks like and how our processes here described. And I will go in further slides more closer into the pipeline here and what exactly the processes that we are doing there. But basically, we have our repository. It can be Bitbucket, GitHub, or whatever else. As long as any changes are done to the code, it goes to the CI environment. We are using Jenkins together with Dockers. I'm not sure if people are aware on what is the Docker and what are the Docker images, but you should be. It's very important right now that everybody is aware on what is this. It is used everywhere, not only in the robotics, but in the any world where you need to scale, when you need to deploy solutions really fast, or when you need reliability on the software. But saying shortly, it's like a virtual machine that is just being able to start much quicker than the normal virtual machine. Within, as soon as any change is done within the code, the continuous integration pipeline is handled by the Jenkins. During this execution of the pipelines, different images are started and different things are happening with the code, and I will explain later on what's there. And while this pipeline is running here, we're constantly collecting the data with the Prometheus, which is, in our case, we are using it more as a database that you can put an extra logic on top of it. So if something goes wrong, or you can put some alerts on whatever data that you're tracking that would notify you either via Slack or Gmail or so on. And at the same time, it allows you an easy integration with Grafana, which is a tool just to display whatever data in a very convenient and pretty way to understand how is your developments progressing. And at the same time, if something is failing within your pipeline, you get a build status, whether it's failed or it's successful on your Slack channel. So now let's delve into what is actually inside of here and what could be the problems with the pipeline. So the first step when you are starting your new Docker image, or when you start your virtual machine, let's say, you do all the verification that are failing the most. So it's basically formatters, starting code analysis. These are the things normally that people forget. The developers don't run every time and forget the most. Again, as I said before, I would advise you to use already programs that do everything for you automatically from the very beginning, so that you don't spend a lot of time on specifying those things, but you can just with basically one simple terminal input correct all the mistakes. You can just within the step verify for those. So the first step would be to check, to make those checks, then compile your program or your solution. Make sure that you compile not only in the release mode, but in debug, because there you could see some, for example, for the profiler, you won't be able to only see it in the release mode, but you would, in order to do extra operation in your code, you would also need to compile it in the debug mode. It is often happen as well that some errors within the memory can show up only in one mode or another. Then within this, also I forgot to mention that within each of those steps, as I put, we will collect some data by the Prometheus database in order to eventually analyze it and display the data that we want. So within every step, I will talk a bit about the information that we are collecting, and I will speak why it is important. So within the compilation step, is the obvious things to record is the compilation time. It can vary a lot, and I advise to keep track on this parameter, because often with unexperienced developers, or just by adding some external libraries to your program, you can increase your compilation time from below minutes to 3 or 4 minutes. And in my opinion, it's very important to try to keep the compilation time as low as possible, because all this time that your developer will be waiting, and often it is required to compile, just to tune some parameters on your robot, it is required to recompile, I don't know, within one day 50 times your code. So that means that extra minute that you put on this compilation would be extra an hour per day that your developer will be just sitting and staring at the terminal. And if you multiply it by 5 developers, it's almost 1 day of one person that is wasted just for this compilation. So I advise to keep track of this and try to keep it as low as possible. Unit tests, low-level tests that normally should focus, in my opinion, on the math algorithms, optimization algorithms, mapping, or something that is normally does not go more than the scope of the class, and can normally runs as a next step after the build process is done. It is also a good way to test interfaces between different nodes or different programs that runs on your onboard computer, just to make sure that if on one side one developer added something, that it won't break things on the other part, or make sure that whatever new things that are added on the one side are compatible and handled by your, let's say, ground control station or nodes within the computer. At this point, you can benchmark or measure low-level algorithm execution time, just making sure that with whatever latest changes you do, your system doesn't slow down. And it can happen over time, or you can, with this information, decide to invest more time in order to reduce some execution time, or you want to reduce some load on the CPU over time, and that would enable you to make those decisions much more mindfully. At the same time, here you can measure your success statistic of your algorithms. If you use some random components in it, or if you do, I don't know, some machine learning algorithms involved in that, you can measure how often did you execute your algorithm successfully or not, and you can also make in the future some decision on how you can steer your development process. And now comes simulations. That's, in my opinion, one of the most important parts. As we speak, as I told you before, we are using Gazebo for that, but any simulation environment can be used. It is really good to test your navigation or dynamic change in environment algorithms. And that's something that in this step, we are running, you can run different numbers of the simulation. So, but the way it looks now, as soon as the code is compiled, we verify it through the unit test. It goes into the stage where we simultaneously start many different simulation scenarios with the turbines in different positions that are executed at the same time. After those simulations is done, and in our current solution, we have around 30 different environments with different turbine models, with different objects around, set in different position. And at the same time, as I told you before, that the error model there might not be good enough for you to verify all your algorithms. You can also use your ROS-back, pre-recorded ROS-back from real flights in order to test your perception algorithms on top of that. And we also have at this point, I think, 10 or 15 different scenarios just based on the pre-recorded data on the field, where we test different types of the algorithms. At the same time, when your product is already released, and of course, initially you will have some bugs and you will be fixing some bugs that you were not aware previously, you would be able to collect those logs from the specific mission, convert it into the ROS-back that's on top of which you can execute your algorithms and add it into your CI process. So basically, every time that you create pull requests, you're making sure that your algorithms are still running correctly and your system output is as what you intended, just by doing all those 30, 40, or whatever tests that you would like to place in. At this point, you can measure your solution performance statistics. For example, how much time did it take for me to survey one blade or one side of the blades, and or how much time it took for me to get from the position where you were on the ground to the tip of the blade. And those statistics would help your business team or management team to also be more mindful about decisions on where we want to steer the development and where we want to invest our time, or which kind of problems we have within our solution. At the same time, you can measure your system load statistics, how much if you are within the operation of your CPU, RAM, GPU, or whatever other stats that you might be limited by. Next one. Defines, just a second. In order to create those scenarios for the simulation or the ROS-back, I would advise to have some program or the script that would steer the scenario and define the rules that tells whether the simulation was successful or not. For that, in our company, for example, we are using the scripts that are able to control the drone and at the same time monitor where it's flying and which kind of action it does. it should be able to check for failure and the success of the overall simulation. It often happens that you wouldn't be able to predict in which way your scenario would fail. So you can just put a timeout on top of it, making sure that if you didn't successfully implement your mission, that the scenario has failed. And within the simulation, it's very important, from what I learned the hard way, is to randomize your environment. One case that happened to us during the development process, we were always testing turbines. So this is a screenshot from the simulation environment. And we were always testing turbine within this position. So those axes define the positive direction. So the turbine was always in the positive direction. And the drone, when it was flying around those blades, it was always staying within the positive localization within this local frame, within the local frame, yes. But when we went on the field and when we started to fly next to the real drone, verifying our algorithms, the turbine was somewhere here in the middle. So half of the blade that is on top was in the positive frame and half was in the negative. And everything went well when we were on one side, and as soon as the drone rotated to the other side of the blade, for some reason the drone has stopped and the program has crashed. So we couldn't fix it at the moment there on the field. It's really hard to get access to this turbine, and so eventually we went back to the office in order to debug what actually has happened. And it appeared that we had a very low-level bug within the math library where if some calculations would go into the negative of the local frame, the program wouldn't just handle and would crash it. So it is important, we would be able to locate this problem before going on the turbine if we would just have a random position around this axis or with the random orientation of the turbine. Then the next step, after simulations are finished and you verify that everything is running correctly, it is important to compile it on your target system. Most probably your development computer and the computer that is running on your robot is different, and it might even have different architecture, and it might have different capabilities for the execution. So it is important that you compile your code on your final computer that is actually installed in the drone, and make sure that your algorithms are executed as successfully there as on your development computers. Important parameters to keep track there is the system load, because it might happen that your less powerful computer on your robot is not able to process as fast as you would like it to do. Also, those binaries that you will compile within this step will be used eventually for the delivery, or can be used for the delivery to the clients. If you compile it for the target system that is on the drone, it means that it can be delivered directly there, and it's compiled within the architecture that you need. Benchmark, system load, algorithm performance stats, whether they're executed fast enough, execution time for some specific parts of your mission, and if you want to run some algorithms similar to the simulations or on your target system, but it might be not powerful enough to do that, and if you would like to simulate the input from the sensors and run the algorithms on top of that, you could just run the ROS-back on your target computer in order to verify if the algorithms are executed successfully on those guys. And then next step, those binaries would eventually ideally and automatically goes to your hardware. In our case, it is a payload that will be that is connected to the drone, or it can be a drone. It can be any robot that you deliver to the client, or it can even be some ground control station that manipulates many drones and remotely controls them. Very important point I would like to mention, that you try to deliver your final binaries to the drone in the same way as your client would do that. So don't just override the binaries on your robot because you have access to the terminal, or you have access to the internal operation system, but try to follow exactly the same user story as your client does, because there might be some steps that you don't take into account, but that might fail during the delivery process, just because you change something within your firmware. And it might not occur if you substitute your binaries just like that. Next one. And as soon as you deliver your binaries to the hardware, verify that within the hardware that all the sensors connected together, or all the electronics, all the power delivery, still all the drivers still works together as they supposed to. And you can also put some automatic checks and tests on top of that within those hardware tests. And if everything works there, you have already the binaries compiled that can be used on the drone. They can automatically or manually, depending on your delivery process, can be delivered to your client, and you can relax and notify him about this either through email or through an app or any other way how your updates are delivered to the robot. And now, just really quick recap and overview on what I said before. So as soon as any changes are done within your code, you compile the code, you collect the information, the compilation time, then running the unit tests, making sure that on the kind of first level of defense, nothing breaks there, your algorithms work as intended. Also, you can collect some information there and log it in your database that you can look over the time. Run all those simulations. It may take a long time. In our case, it sometimes takes 4 or 5 hours to do that. If everything works there, make sure you compile the system for on exactly the same platform, the same architecture that is used on your drone. And again, collect information, how is it everything executed there if you don't exceed limitation of your CPU, GPU, or any other parameters that you have. If you do exceed those parameters, and it is pretty, you can write a logic that would already tell you that you might have some problems there within your code, and that some algorithm has to be notified. Or you could even just within the step fail your pipeline and deliver the status over the Slack. And then hardware tests, if everything goes fine there, all the drivers are still in place, everything is working, deliver it to the client. And at the end, you can enjoy some nice graphs where you can see the progress of your development, or how the load on the system is increasing or decreasing, depending on what are the goals that you set in front of yourself. And I think that's all. Thank you very much. Thank you for the attention. And I think I will have now time for your questions.
Окей, так. Дякую, Ілля. Давайте перейдемо до питання. Питань трохи є. І, до речі, я забув сказати, що подарунком за найкраще питання буде не тільки книжка, але ще й буде брендоване термогронятко від нашого спонсору SoftServe. Так що, як говориться, зараз почитаємо. І, Ілля, нагадую, ти вибираєш переможця. Отже, від Віктора в нас питання. У нас, ряд питань. Значить, if you, значить,
if you have usual software, this one?
Цей, тобто, чи, я прочитаю англійською. If you have usual software development process, then probably definition of ready and definition of done should include those things about documenting. Do you practice such thing?
To be honest, we either don't, or I'm not really aware of this documentation of readiness. I don't know those terms, and I'm not sure if we have something like that. So I cannot reply. Maybe we have something similar, but I'm at least not aware of those terms. So I cannot reply, sorry.
Наступне, a part of the static analysis, do you use some kind of dynamic analysis? If yes, which tool you generally use for that?
Yes, as I said, we, and as I show you, we have the simulation environments. For that, we use Gazebo. And on top of those, we are writing our own plugins for the sensors in order to get as close as possible to the error model of the environment that we collect during the real flights. So within this Gazebo simulation environment, you can create dynamic environments, static environments, or any other. In our case, it's mostly static because the turbine does not rotate when we are inspecting it. Although the tips of the blades, they move with the winds. So they have a deviation like maybe 1-2 meters back and forth. And even though we could program it within the simulation, we don't, because it's our software can handle it, even assuming that it's static.
Ілля, я перепрошую, але я тут, можливо, контекстуально, знову ж таки, можливо, тут йдеться про статичний аналіз коду і про динамічний аналіз коду.
I think I'm not sure if the profiling counts for that. Если не считается, то значит нет, то мы не делаем.
Okay. Are you implemented real-time systems? If yes, how strictly your requirements are? Or maybe your system is partly real-time? How do you test and particularly collect real-time related metrics?
Our system is not real-time, so everything that is happening real-time, it's on the side of the autopilot of the drone. So we are more just communicating with it and telling it where to fly, with which coordinates, and controlling some parameters of the drone. But our system is not real-time, and to our solution, it is not required.
Okay. Do you use Kubernetes?
No, we don't.
Which metrics you visualizing on Grafana?
Thread execution time. So for us, it's very important that we can process every readings of the LiDAR, and we operate in real time to our data readings from the LiDAR. So in our 10 hertz. It is very important for us in order to be able to build odometry and the map of the environment, and it significantly improves the quality of the map that we built. So we keep track, and we are making sure that all our threads are executing within 100 milliseconds, so it's 10 hertz. And as soon as any of those parameters goes above, in sum together, we try to focus on the ones that taking the most time. So I would say one of the most important parameters is execution time, compilation time, and the execution of some specific threads that are communicating with the drone or that are building the odometry.
Okay. Why do you have a static code analysis before compilation?
I think we have before and after. I cannot tell exactly, but there are tools that can do it before the compilation, and there are tools that can do it after. Actually, I combined everything there in one step. Otherwise, this pipeline would grow. Actually, we have many more steps, and they're divided in more places. I tried just to group them together since they are related.
Do you use some kind of parallelizing or distributed compilation?
We don't, because the compilation doesn't take much time. What we are doing is we are parallelizing simulations. And for that, we have a server internally in our company with quite powerful CPU, actually several powerful CPUs, where we distribute the simulation, because each of them takes up to 20 minutes, and running 20 of them would take too much time. So that's the only thing that we are parallelizing that take the most of the time.
Okay. Do you use interfaces/contracts to keep API stable in case of active parallel development of the code?
for that, we use unit tests that automatically, and we have some tools on top of that, that as long as you update definition of APIs within some specific files, they will be unit tested over each other to see if they're compatible and from all sides if it's properly handled.
Okay, and what about test-driven development?
In our case, it was, as a startup, we mostly underfunded and we need to over-deliver. I think you can allow yourself to follow test-driven development when you are already a big company with a steady income, and you can put reliability in front of the delivery. But in our case, it was always we need to show something that is working, and then afterwards to make sure that what is working is reliable. So even though I respect that way of development, but in our case, it didn't work, up at least until this moment.
Okay, an interesting question. How do you stabilize drones when analyze blades for offshore wind turbines, especially when high winds like 18, 22 meters per second, or when generator overspeed? Interesting. Mm-hmm. This is actually because sometimes impossible to catch back the lost drones in this offshore inspection.
That's an interesting. There are many challenges when you go offshore, but to be clear, we always stop the turbine. We never inspect turbine when it's rotating, so we always stop the turbine in a specific position in order to do this inspection. Limitation on the wind speeds are defined mostly by the specification of the drone. So we are drone agnostic, and what we are building is the gimbal or the attachment with the drone with onboard computer and sensors. So as long as the drone that we are using allows to go 20 meters per second or 30 meters per second, we can use it and we can fly it. So there is no limitations on the software side for that. One interesting thing about the offshore operation is that it is by, I think, all European countries' law, it is obligatory that you need to have some kind of inflatable buoy or an inflatable thing that would keep the drone on top of the water. Because if something falls out of the ship, and in this case it would be within this category, they must finance the operation in order to get this drone out of whatever fell down to the bottom of the ground. They must rescue it and they must deliver it from the bottom. So I know from it didn't happen with us, but with some other companies that did manual operation with the drone, and they didn't have inflatable. Actually, they had an inflatable thing on the drone, but it didn't work. So the drone drowned, and I think the company spent around 100,000 euros in order to get it from the bottom of the ocean.
Okay. Наступне питання. Where are you keeping ROS bags which you are using for tests? You probably have a lot of ROS bags. How do you manage all these data?
So you can keep those ROS bags, and we are keeping it on AWS. We put, so since we are doing up to this date, we did more than 10,000 or maybe 15, around 15,000 blades. We put all old data into the cold storage, and those ROS bags that are used for the tests and for the continuous integration and delivery, we keep locally on the server. And normally we have 20 to 30 of them just for the tests, and it's not that much space to have on one computer.
Okay. And do you use virtual machines configured as much close to your target hardware for testing as possible?
Yes, we do, although they're on different architecture. So I'm not sure actually if it's possible to keep within the Docker or virtual machine and the ARM architecture. Maybe it is, but we just make sure that the packages are the same, and Yeah, and we have the same kind of installation procedure that we follow installation scripts for one system and another.
Yeah, just small comment. Yeah, it is possible, and actually we use it for Raspberry Pi, which is ARM-based, so it's quite cool.
Okay, well, that's interesting.
Yeah. How do you share boards or other hardware between developers?
We don't, because most of the things also you can have exactly the same environment for the development on your computer in terms of the high-level software as you would have on the board. Of course, you would need to have boards to develop some drivers to make sure that the hardware is compatible, but some time ago it was possible to do it at the office and all the hardware was at the office. Right now, since we went remotely, the necessary hardware is delivered to the house of our developers when after all the tests are being done. It's just integrated into ICR process, and then it's automatically tested at the office with the hardware.
Okay. Did you have any thermal related overheating issues with your hardware?
We did, and the solution to that was to make more holes into this enclosure that holds our boards, and then just make sure that you put some IP protection film in between. But we did have our hardware fail, especially in Brazil, where when they are operating closer to the equator, we had issues that the hardware just completely died.
Okay, and the last question, what do you think about blade position that is moving close to the tower? In other words, can wind waves from tower influence blade and decrease performance of the wind turbine? Do you have comparison of your simulated data and real data from production?
This is more a question to the people who produce wind turbines, but not us, but I still think I know the answer to this question. So our company is focused on inspecting the surface of the wind blades, but not increasing the performance per se of the wind turbines. But every time when the wind turbine is rotating and working, it's pointing towards the wind. So that means that the turbine or the tower will be behind the blades. So the wind is always in front, and the blade will be always in front of the tower relative to the wind. The nacelle or the top part of the turbine can rotate towards the wind.
Yeah, the last question actually, so I probably missed it in my chart. So can you please recommend a book, a documentation or tutorial on ROS for Windows? The same applies for Gazebo.
To be honest, no. I started to read one book on ROS. It was not for Windows, and I wouldn't recommend to work on Windows with ROS. I don't know how ROS2 support Windows, but from any experience that I had with Windows in combination of ROS, it is really a pain. I started to read one book, but for me it felt that it was a very I don't know. It was lacking the real. I didn't like the book, so I tried few articles, a few books, but none of them was given enough information that I wanted. So I cannot recommend any, and everything that I learned was mostly from forums, some tutorials on the internet, or just looking into open source projects. I would advise to focus on the open source projects, see how they are implementing things, or just some people on the GitHub with short and simple projects and see how the things are done there. But I'm sorry, I cannot recommend any books. I don't know.
Окей. Так, подякували. Ну, в принципі, питань більше немає. Відповідно, пропоную Іллі вибрати найкраще питання. Яке питання тобі здалося найвдаліше?
Мне понравилось больше всего это вопрос про разные архитектуры и системы. Это что-то, чего я не знал, и что я сегодня тоже выучил, что можно на разных докерах разную архитектуру компилировать. И этот вопрос, мне кажется, был от Виктора Шум.
Віктора.
Так.
Супер, Вікторе. Ну, як говориться, статистично перемога була майже в Віктора в руках, враховуючи кількість питань. Дуже дякую Віктору. Вікторе, чи ти можеш якісь лишити електронну пошту, щоб з тобою зв'язалися організатори для вручення призів?
Я додам, що ми маємо пошти усіх учасників, тому ми обов'язково сконтактуємо з переможцем.
Ага, окей, супер. Ну, тоді вітаємо. В принципі, я хотів би дуже велике дякую сказати Іллі. Ілля дуже зайнята людина, і, як говориться, ми з ним вели дуже активний діалог, щоб знайти оцей часовий діапазон. Ну, знову ж таки, не дуже вгадали, бо в нього знов, як говориться, мало часу, ну, але дякую, що ти зібрався, виступив. Дуже цікава доповідь, та, насправді, я ще раз кажу, з практики, робототехніки, це дуже круто, ти маєш реальний практичний досвід. Ось, так що бажаємо вам успіху, щоб ваш стартап виріс в компанію, де TDD у вас буде не, як говориться, розкіш, а будення. Ось, це, чи навіть BDD, Behavior Driven Development. Ось, так що дуже тобі дякую. Дуже дякую компанії SoftServe за організацію цього прекрасного дня сьогоднішнього. Ну і нагадую, що в нас буде завтра доповідь про AWS. Як AWS працює з роботами. Ось, так що приходьте, всіх запрошую. І якщо ви не зможете, то буде відеозапис, і ми його викладемо в нашу групу ROS-Ukraine на YouTube. Дуже всім дякую і всім гарного вечора.
Спасибо вам большое тоже. Было очень приятно.
Щасти.